March 22nd, 2010. A control room in Pasadena, California, is completely silent. They are waiting for a sound. A faint, familiar signal, the kind that has crossed the dark between two worlds more than 1,000 times before. A daily heartbeat sent home from the surface of Mars. The great dishes are turned toward the red planet. Everyone is listening. 90 minutes pass. Nothing comes. The next day, nothing. The day after that, nothing. Over the months that follow, the engineers send more than 1,300 commands out into the dark, each one a small question thrown across 100 million miles. Each one goes unanswered, and slowly they understand what has happened. The machine they are calling is a 6-wheeled rover the size of a golf cart. Its name is Spirit, and it has just gone quiet, half sunk in the Martian sand, after surviving 25 times longer than anyone ever expected it to. But here's the part almost nobody talks about. In its final months, stuck, dying, scraping at the ground beneath its own broken wheels, Spirit had uncovered something it was never built to find. Something that made a room full of scientists gasp out loud. To understand what it found and why it still matters, we have to go back to the beginning, to a child who gave it its name, and a mission that was only ever meant to last 90 days. Let's start with the simplest fact, because almost everything that follows bends it out of shape. This rover was built to live for 90 Martian days. That's it, about 92 of our days, 3 months. After that, NASA expected the dust to win. The whole mission was designed around that short window. Its name came from a 9-year-old girl named Sophie Collis, who won a NASA essay contest to name the twin rovers. 2 machines, launched about a month apart in 2003, sent to opposite sides of the same planet. One was named Spirit, the other was named Opportunity. They were twins. 6-wheeled, solar-powered, about the size of a golf cart, each one carrying a small arm, like an insect's, that could reach out and touch the rock of another world. Now, here's a detail most people never hear. Bolted onto both of these rovers were pieces of metal recovered from the fallen World Trade Center, a fragment of one tragedy on Earth, riding along on a search for water on Mars. And that wasn't the only piece of grief built into Spirit. The rover launched in June of 2003 from Cape Canaveral, and 7 months later, in January of 2004, it dropped through the thin Martian sky and bounced across the ground inside a cocoon of airbags before rolling to a stop almost exactly where the team had aimed it. It came to rest inside a place called Gusev Crater, and the team gave its landing site a name: Columbia Memorial Station. They named it for the 7 astronauts who had died less than a year earlier when the space shuttle Columbia broke apart in the sky as it came home. So before Spirit ever sent back a single image, it was already carrying 2 memorials with it. That's the emotional weight this machine left Earth with. And then, almost immediately, it nearly died. Just over 2 weeks into a 90-day life, NASA lost contact. Something deep inside the rover had thrown it into a fault, and the brand new machine, the one carrying all that meaning, simply stopped talking. The engineers coaxed it back. Within a couple of weeks, Spirit was awake again, and one of the first things it did was reach out with its arm and grind into a rock. The team had named Adirondack the first time a machine had ever ground into a rock on the surface of Mars. It worked. The crisis passed. And once it was healthy, Spirit began doing what it came to do. It sent home image after image, more than 100,000 of them over its lifetime. In its first weeks, it took the first photograph of Earth from the surface of another planet. Our entire world, reduced to a single faint point of light in a strange evening sky. And it found science almost right away. Exploring the hills around its landing site, Spirit turned up a surprising variety of rock, and some of it carried the faint marks of having been touched by water long ago. The clues were already there, this early. The team just didn't yet grasp how deep they ran. But remember that first brush with death. A piece of hardware fails, the team improvises, the mission survives, and the failure quietly opens a door no one expected. Because that pattern failure becoming discovery is the whole story of Spirit. It just took a few more years and one dead wheel before anyone realized it. To understand the discovery, you have to understand the people waiting for it on Earth, and you have to understand one decision made by one scientist that almost didn't happen. His name was Steve Ruff. He was a geologist at Arizona State University, and his job on the mission was an unglamorous one. He ran the day-to-day operations of an instrument called the Mini-TES, the Miniature Thermal Emission Spectrometer. It was a tool that could look at a rock or a patch of soil from a distance and read the minerals inside it, almost like reading a barcode made of heat. Ruff was the kind of scientist who noticed things other people drove past. By 2005, Spirit had already done more than anyone dreamed. It had crossed rocky, sandy ground and climbed all the way to the summit of a rise called Husband Hill, where it took true-color panoramas of the entire crater spread out below. It had survived a winter. It had survived that early memory fault. The 90-day machine was now measured in years. But the mission was a grind. Day after day, the rovers crept forward at about an inch every few seconds, surveying soil, watching for dust devils, checking the sky. Most of what they found was the same volcanic basalt over and over again. So when Spirit's wheels churned up another patch of disturbed soil near a flat, layered plateau, the team had nicknamed Home Plate. They had seen bright soil before. It was usually rich in sulfur. Another sulfate patch. Move on. Ruff didn't move on. He looked at the Mini-TES reading and saw something the others had missed, a signature that hinted not at sulfur, but at silica. And he didn't just mention it quietly. According to the people in the room, he pushed. He told the team, in so many words, that they had to go check this out. They had to stop, turn the rover around, and put the arm down on that exact spot. One of his colleagues remembered the reaction. Ruff said, "This looks different. It's got silica in it. You have to go check this out." And everyone else sort of went, "Okay, fine, we'll check it out." It was not a dramatic moment. It was one man looking at a faint line on a graph and refusing to let the team drive past it. That refusal is the hinge the entire mission turns on. Because the patch of soil Ruff was pointing at would soon make a room full of scientists gasp out loud, and it would have stayed buried forever if it hadn't been for a part of Spirit that had completely broken down. Now we come back to the wheel. In March of 2006, after Spirit had already driven several kilometers across Mars, the drive motor in its right front wheel simply quit. It stopped turning, and it never turned reliably again. For a six-wheeled rover, losing a wheel is serious. The engineers' solution was almost absurdly simple. They started driving Spirit backward, dragging the dead wheel behind it like a stubborn child's heel scraping the ground. And here's the part that matters. That dragging wheel wasn't just dead weight. As Spirit reversed across the surface, the locked wheel plowed a trench a few inches deep, scraping away the top layer of dirt and exposing whatever was hiding just beneath it. A broken machine had accidentally become a digging machine. For a while, this just churned up more of the usual bright, sulfur-rich soil. But near home plate, dragging that ruined wheel through the ground, Spirit scraped open a patch that looked almost white. The team gave it a name, Gertrude Wise, after a player from the All-American Girls Professional Baseball League. In fact, they named a whole cluster of these bright soil targets after women from that league. Then they did what Ruff had been pushing for. They drove Spirit back to that white trench and pressed the chemical analyzer on its arm, the alpha particle X-ray spectrometer, directly onto the soil. And this is the single fact this entire story is built around. So I want to slow down and sit with it. The soil at Gertrude Wise was about 90% pure silica. Let that land. Silica is the main ingredient in window glass. On Earth, you mostly know it as quartz. And here was a patch of Martian dirt that was nearly all of it, 90% sitting just beneath an ordinary-looking surface. When the result came back during a team teleconference, one of the scientists described the moment perfectly. You could hear people gasp in astonishment because they understood immediately what it meant. You do not get a concentration of silica that pure by accident. As one of the geochemists on the team, Albert Yen, put it, he didn't know of any way to concentrate that much silica without liquid water, on a planet that is now bone dry, frozen, and dead. And the most extraordinary part? They only found it because the wheel was broken. The principal investigator for the rover's instruments, Steve Squires of Cornell University, said it plainly. They wouldn't have found this if the bad wheel hadn't been bad. He called it a phenomenal silver lining. The single worst failure on the mission had dragged open the single best piece of evidence for water that Spirit ever found. Squires said, "It made you wonder what else was still out there." The rover had worked within about 50 yards of that spot for more than 18 months before it ever uncovered it. 18 months, a few dozen yards away, and the only reason it finally scraped the right patch of ground was that one of its legs had stopped working. So how does a planet end up with a patch of nearly pure window glass buried in its soil? To understand that, we have to teach the chemistry the way the scientists worked it out slowly, one clue at a time. Start with the rock all around it. The ground near home plate is basalt, ordinary volcanic rock, full of minerals like olivine and pyroxene, the same dark stuff you'd find in a lava flow on Earth. Basalt is everywhere on Mars. It is the planet's default. Now, basalt usually doesn't explode. When it erupts, it tends to ooze out as runny lava. But the team came to believe that home plate itself was the remnant of an explosion, an ancient volcanic blast. And there's a clean way to make runny basalt explode. You let it touch water. When molten rock meets water, the water flashes to steam, and the pressure of that steam blows the whole thing apart. The evidence for this was written into the rocks. The team found high levels of chlorine, which can mean the lava met a salty brine. They found coarse grains lying on top of finer material, exactly the pattern you'd expect from debris falling back down after a blast. And, most tellingly, they found something they called a bomb sag. A place where a rock thrown up by the explosion fell back down into soft, wet ground and left a dent, deforming the layers as it landed. You don't get a bomb sag in dry dirt, you get it in wet sediment. So the picture starts to form. Long ago, this was a place where volcanic heat and water met violently. And where you have volcanic heat and water together, you get one of the most interesting environments in all of geology. A hydrothermal system. Hot springs, steam vents, fumaroles, the kind of thing that powers Yellowstone. Here's how that makes silica. Hot, acidic water and steam move through the basalt. They dissolve and strip away everything they can, all the other elements, and leave behind the one thing that won't dissolve as easily: silica. Or, in the other version of the story, silica-rich water flows through, then evaporates, and leaves the silica precipitated out in place. The team found evidence pointing toward both. Either way, the answer is the same. Either way, you need water. This is why the gasp in that teleconference mattered so much. The silica wasn't just a strange mineral. It was a fingerprint of a warm, wet, possibly life-friendly world that existed on Mars billions of years ago. And it didn't stand alone. Spirit had already found other hints of long-gone water scattered around this same site. There was a place the team called Tyrone, where the rover had churned up bright soil loaded with sulfur and a trace of water soil that could have formed around ancient gas vents or been left behind when mineral-rich water rose to the surface and evaporated away. Piece by piece, a single story was assembling itself out of the dirt, heat and water and chemistry, all working together here long ago. The closest thing to it on Earth is a place you can visit. The combination of volcanic heat and groundwater that the team kept finding evidence for is exactly what powers the hot springs, the geysers, the bubbling mud pots, and steam vents of Yellowstone National Park. And on Earth, Those hydrothermal systems are not lifeless. They teem with it. They are some of the most crowded, thriving environments our planet has, microbes living in water that would kill almost anything else. So when scientists looked at Spirit's silica and thought of Yellowstone, they weren't just thinking about geology, they were thinking about the possibility that Spirit had stumbled into the Martian ruins of exactly the kind of place where, on Earth, life loves to live. And there's one more detail here. I'm going to mention it now, and then I'm going to let it go, because it didn't seem important at the time. When Spirit looked closely at the silica, the deposits weren't smooth. They formed strange little shapes, knobby, nodular lumps, and tiny finger-like structures pointing up out of the ground. The team noticed them. They didn't quite know what to make of them. The best guess at the time was that the Martian wind had simply carved them that way over the ages. So they noted the odd little fingers of glass, and they moved on. Remember them. For most of its life, Spirit was a machine that refused to die. But the way it kept surviving was almost as strange as what it found. Its great enemy was dust. Spirit ran on sunlight, drawing power through solar panels, and as Martian dust settled on those panels, its power slowly bled away. Every dusty day, the rover grew a little weaker. By the logic of the mission, this is what was always supposed to kill it. Except, again and again, the planet saved it. In March of 2005, something peculiar happened. Dust devils, small whirlwinds, passed directly over the rover and swept the dust right off its panels. Spirit's power jumped from around 60% of its normal level to 93% overnight. The wind, the very thing carrying the dust, had cleaned the rover and handed it more life. This kept happening. A failure would push Spirit toward the edge, and then a gust of Martian wind would pull it back. And it wasn't only the big systems that wore down. The machine was aging in 1,000 quiet ways. The diamond grinding bit on its rock abrasion tool, the tool that had made history on that first rock back in 2004, slowly wore away, until eventually it could no longer grind at all, only brush. Even the heart of one instrument was decaying on a schedule set by physics itself. The Mars spectrometer relied on a radioactive source that faded steadily over time, its strength halving roughly every 9 months, so that near the end it took longer and longer to gather a single reading. Spirit was, very literally, running down, getting slower, getting weaker, an old machine on a cold planet, doing less each day than the day before. But the failures kept stacking up, and I'm not going to pretend each one was equal, because they weren't. The pattern was always the same. Something breaks, the team scrambles, the rover limps on, and the rhythm of that pattern is the real story here. The first true blow was the right front wheel in 2006, the one that turned into a discovery. That one mattered most. After that, they came faster and meant less. Each one just another turn of the same wheel of attrition. The summer of 2007 brought enormous dust storms that choked both rovers, starving them of light. A winter storm at the end of 2008 dropped Spirit's power to about 89 watt-hours per Martian day, when a healthy day was around 700. At that level, the rover had to live off its own batteries, and if those batteries ever ran dry, that would be the end. Through 2009, more lucky winds cleared more dust, and by that April, Spirit had clawed its way back up to roughly 372 watt-hours a day, enough to do real science again. Failure, rescue, failure, rescue. The same beat over and over, and then came the one it couldn't survive. On the 1st of May, 2009, while driving south alongside the western edge of home plate, Spirit's wheels broke through a thin crust on the surface and sank into soft sand underneath. The team named the spot Troy. This was no ordinary patch of dirt. Beneath that innocent-looking crust was a hidden cache of iron sulfate, a mineral with almost no cohesion, like trying to get traction in a pit of dry flour. Spirit's wheels spun, and the more they spun, the deeper they dug. The machine was, in the most literal sense, sinking into the planet. For months, NASA fought to free it. Engineers built a duplicate sandbox on Earth, buried a test rover in simulated Martian soil, and ran the escape attempts over and over before sending a single command to Mars. They tried tiny wiggles of the wheels to plow through the resistance. In its very best stretch, Spirit clawed about 34 centimeters backward over 10 desperate drives. It wasn't enough. And the planet wasn't done taking pieces. In late November of 2009, a second wheel, the right rear one, stopped working too. Now Spirit was down to 4 wheels, stuck on a slope, in a trap it could not climb out of. By late January 2010, NASA made the call. They stopped trying to free it. Spirit would no longer be a rover. It would become something else, a stationary science platform, rooted forever to the spot called Troy. Here's the strange part. Getting stuck was a catastrophe, but the trap itself became a discovery the same way the broken wheel had years before. Because while Spirit was hopelessly buried at Troy, struggling for traction, its flailing wheels were doing exactly what the dead wheel had done at Gertrude Wise. They were digging. They were churning up bright soil from beneath the surface and laying it bare for the instruments to study. And the rover wasn't going anywhere, so for once, it had all the time in the world to look. What it found in that trap told a story scientists hadn't expected. The soil at Troy wasn't uniform. It came in layers, different compositions stacked just beneath the surface. Near the top sat the minerals that don't dissolve easily, things like silica and gypsum, and an iron oxide. But deeper down were the ferric sulfates, minerals that dissolve readily in water. That ordering is a clue. If water had once trickled down through this ground, it would have dissolved the soluble minerals and carried them deeper, while leaving the stubborn ones near the top, which is exactly the pattern Spirit was sitting in. The team's deputy principal investigator, Ray Arvidson of Washington University, explained what made it so striking. None of these minerals were exposed at the very surface. They were covered by wind-blown sand and dust, and the Martian wind is constantly stripping the surface away, reshaping the land. So for the layering to still be there, the process that made it couldn't be ancient and finished. It had to be relatively recent and ongoing. The proposal that came out of this was remarkable. Thin films of water, perhaps from melting frost or snow, may have been seeping into the ground at Troy, not billions of years ago, but during the planet's more recent cycles, as Mars slowly tilts back and forth on its axis over hundreds of thousands of years. Sit with what that means. The very sand trap that doomed Spirit had pried open evidence that liquid water, in small amounts, may still trickle through the Martian soil during certain seasons of the planet's long, wobbling year. The machine had found one last secret while drowning in the sand, and there was supposed to be one more. As a stationary platform, Spirit was given a new job, perhaps its most ambitious yet. By sitting perfectly still and letting scientists track the tiny wobble in its radio signal as Mars rotated, it could measure the planet's spin precisely enough to reveal what was hidden at the very center of Mars, whether the core of the planet was liquid or solid. To do it, though, the rover needed to tilt its solar panels toward the winter sun in the northern sky, just enough to stay alive through the cold. In the end, the desired tilt was never achieved. Before we reach the silence, it's worth stepping back to ask a simple question. Was any of this normal? How does Spirit compare to everything else we've sent into the dark? Start with the lifespan, because it's almost hard to believe. Spirit was built for 90 days. It ran for 6 years, 2 months, and 19 days. That is more than 25 times its intended life. Imagine buying a machine rated to last 3 months and having it still working on another planet. 6 years later, it drove, too. The plan called for it to travel maybe 600 meters in total. Instead, it logged about 4.8 miles, roughly 7.5 kilometers, grinding across the Martian plains, one slow inch at a time. Then there's the company it kept in the record books. For a long time, The longest surviving machines on the surface of Mars were the old Viking landers from the 1970s. But the Vikings had an advantage. They were powered by nuclear sources. Spirit ran on nothing but sunlight and luck. And in August of 2007, this solar-powered rover quietly passed the Viking 2 lander's endurance record, beating it by a single Martian day. It crept toward Viking 1's record too, and fell just over a month short before its voice went quiet. A machine that fed on sunlight nearly outlived the nuclear giants that came before it, and it had a twin to measure against. Opportunity landed on the far side of the planet, kept going even longer, well over a decade. Both of them dwarfed their tiny predecessor, the Sojourner rover from 1997, which had been about a seventh of their weight, no bigger than a microwave with wheels. In a single generation, our machines on Mars had grown from toys into long-haul explorers. The two of them would loom so large in the story of space exploration that, years later, their long journey became the subject of a documentary film, a love letter to two robots that simply refused to quit. And the knowledge didn't die with them. The lessons learned driving Spirit and Opportunity were poured directly into the rover that came next, Curiosity, which can now sense when it is rolling into dangerous sand and stop to ask its handlers on Earth for help, a caution learned, in part, from watching Spirit sink. Along the way, Spirit had even turned its cameras to the sky and become an astronomer. It watched one of Mars's 2 little moons slide in front of the sun. It caught the other vanishing into the planet's shadow. It studied the dust that was slowly killing it and discovered that every speck of it was magnetic Martian dust laced through with iron, so magnetic that a single magnet on the rover could pull it straight out of the air. But the most important comparison isn't about size or distance, or even the strange beauty of an alien sky. It's about the silica. Because while Spirit sat frozen at Troy, scientists back on Earth went looking for a place that could explain those strange little finger-shaped structures it had photographed near home plate, the ones everyone had shrugged off as wind carving. They found it in the mountains of northern Chile, at a place called El Tatio. It sits over 14,000 feet up at the edge of the Atacama Desert, one of the driest places on Earth. The air is thin and floods with ultraviolet light. The nights drop below freezing. It is, in almost every way that matters, the most Mars-like hot spring on our entire planet. And in the discharge channels of those Chilean hot springs, scientists found silica structures, nodular, finger-like shapes that looked nearly identical to the ones Spirit had found on Mars. That should have been the satisfying end of the story. Same shapes, same hot spring chemistry, mystery solved. Except for one detail about how those shapes form at El Tatio. And that detail is where this entire story stops being about a broken machine and starts being about something much larger. Remember the strange little finger-like structures in the silica? The ones the team noticed near home plate and set aside, guessing the wind had shaped them. At El Tatio, structures with that exact shape and size are not carved by wind. They are built with the help of life. In the shallow, warm water of those Chilean discharge channels, microbes, mats of bacteria, films of living organisms grow in the flowing water. As silica precipitates out around them, it entombs them, layer by layer, and over time it builds up those same knobby, finger-like towers. Two ASU scientists, the geologist Steve Ruff, the same man who refused to drive past Gertrude Weisey, and the astrobiologist Jack Farmer, studied them closely. Under the microscope, inside the Chilean structures, they found the silica-wrapped threads and filaments of the organisms that helped make them. They even found a second fingerprint hiding in the data, a thin, patchy crust of ordinary salt halite coating the Chilean silica, which warped the heat readings in a very particular way. And when they went back to Spirit's old readings from Mars, some of them carried that same strange signature. The same salt, the same shapes, the same chemistry. The shapes on Mars and the shapes in Chile are, to the eye, the same. On Earth, the ones at El Tatio are what geologists call microstromatolites, structures built by communities of microbes layered into stone. Now, the scientists were extraordinarily careful here, and we have to be too. They did not claim they had found life on Mars. They went out of their way to say the opposite, that fully non-living processes could not be ruled out, that wind and chemistry alone might still explain the Martian fingers. Spirit didn't carry the instruments to look for microscopic fossils. It couldn't settle the question. Nobody can, not yet. But there is a specific term for what they concluded, and it was defined by a NASA science team for exactly moments like this: a potential biosignature, an object, a substance, or a pattern that might have a biological origin, and that compels investigators to go gather more data before deciding whether life was ever there. Because nobody could prove the Martian fingers of glass were made by life, and nobody could prove they weren't, they met that definition exactly. The silica that Spirit's broken wheel had dragged into the sunlight was, formally, a potential biosignature. And the scientists noticed something else that made it almost unbelievable that we could still read it at all. On Earth, this kind of silica is unstable over long stretches of time. It tends to transform into harder, more ordinary forms. But the silica at home plate had stayed in its original, delicate state, barely changed across billions of years. Whatever was written into those shapes, the planet had preserved it, almost perfectly, the whole time, as if Mars had been keeping the evidence safe, waiting for someone to come and read it. That's why this site climbed the list. When NASA's scientists later argued over where to send their next great rover, the Columbia Hills and home plate, the very ground Spirit had crawled across ranked near the very top of the candidates, second only to an ancient lake bed in a place called Gusev Crater. As the scientists put it, this was a known hydrothermal deposit. They knew exactly where to land and exactly where to go to collect the samples. Spirit had drawn the map. Think about the chain of accidents that led here. A wheel had to fail. A man had to refuse to drive past a faint reading. A rover had to get stuck. And years later, someone had to read a paper about a hot spring in the Chilean desert and recognize the shapes. The little white trench that made a room full of scientists gasp wasn't just evidence of ancient water. It was, possibly, the closest thing we have ever found to a place on Mars where something might once have been alive. And it sits there still, near home plate, in the Columbia Hills, waiting for a machine that can finally answer the questions Spirit could only raise. So we come, at last, to the cold. Through every winter before, Spirit had survived by tilting itself toward the sun, parking on a north-facing slope to soak up enough warmth to keep its heart beating. Those survival heaters were the difference between life and a death by freezing. On a good slope, the rover could keep its insides above roughly 40 degrees below 0 Celsius. But Spirit was stuck on flat ground now. It couldn't find the angle. It couldn't catch the light. With its wheels buried at Troy and the winter sun hanging low in the wrong part of the sky, the team could no longer give it the tilt it needed. Its internal temperature is estimated to have dropped to around 55 degrees below 0, colder than it had ever been. Cold enough that the delicate connections inside it, the wiring, the electronics, the parts that make a machine, would be at the mercy of the freeze. On the 30th of March, 2010, Spirit skipped a scheduled call home, almost certainly slipping into a deep, low-power hibernation, shutting down everything to try and save itself. Its last contact with Earth had come a few days earlier, on the 22nd of March, 2010. After that, nothing. NASA did not give up easily. For more than a year, the great dishes of the Deep Space Network listened and listened, and sent command after command into the dark, more than 1,300 of them in all, hoping that a cleaning event, a gust of wind, a stroke of the same luck that had saved Spirit so many times before, might wake it one last time. The wind never came. On the 25th of May, 2011, NASA announced that the effort was over. The most probable cause was simply the cold, the long, sunless Martian winter that had left the rover without enough energy to run the heaters that kept it alive. They declared the mission complete. The instruments that had been listening for Spirit were turned toward its twin, Opportunity, still rolling on the far side of the world. Spirit had been silent for over a year by then. It is silent still. There is one more thing worth knowing about where Spirit rests. It is not truly safe there. The spot at Troy sits beside an encroaching field of Martian dunes, slow rivers of sand, pushed by that same restless wind that once cleaned its panels and kept it alive. And those dunes are moving toward it. In time, they may cover it completely. Some of the scientists who think about these things have started to call the rover something we don't usually apply to a machine: an artifact. A piece of human heritage on another planet, as worth preserving as a footprint or a stone tool, a marker of the first time our species reached out and touched the surface of another world and left something of itself behind. They worry that once the sand closes over Spirit, it may become very difficult to ever find again. So picture it the way it is right now. A small, broken machine sitting tilted in a shallow crater on the side of a dead volcano, its wheels half sunk in soil that may still feel the touch of water. Around it, the dunes drift slowly closer. Above it, the same pale sun it spent 6 years chasing. And just beneath its wheels, in a trench it dug while it was dying, lie strange little fingers of glass that we cannot yet prove were shaped by the wind, or by something that was once alive. We sent a 90-day machine to look for signs of water on a planet we were sure had none. It lasted more than 25 times as long as we asked. It broke again and again, and every time it broke it seemed to find something it never could have found whole. And in the end, half buried and going cold, it scraped open a question so large that we have had to build new machines and dream up new missions just to begin to answer it. The wind is still blowing across Gusev Crater tonight, the dunes are still moving, and somewhere under that drifting sand, a small, faithful, broken thing is still holding onto the most important secret it ever found, waiting, patiently, for someone to come back and dig it out.